In this last part of chapter 6, what we're going to do is try to fit a trend line, or a line of best fit if you like, or very similar to a regression line, and use it to predict things as well. So we're going to fit a trend line by using the least squares regression model that we've done previously in chapters 3 and 4. And then we're going to use it to predict things outside the data set. We're going to need to be able to do predictions where we've taken seasonality into account, but also with deseasonalized data. Example 6E.1. Fit a trend line to the data in the following table, which shows the number of government schools in Victoria over this period. And then how many government schools are predicted for Victoria in 2015 if the same trend continues? Give your answer the nearest whole number. Now, it does say in the instructions that we're letting 1981 be 1, 1982 equals 2, etc. Please be aware of instructions like this, because that will be really important when you're making your regression lines, because if you use the numbers as they are, you'll get bizarro big old numbers. So we're actually going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're going to go, this is a little bit retro, I feel like. We're going to go back to your old statistics, and we're just going to make a big old graph. Please be aware though, of course, if it doesn't actually say the instructions, let 1981 equals 1, 1982, then you please write 1981, 1982, and that kind of thing. So we're going to get a good old regression going on here. List 1, list 2. We're going to find out what the formulas is and all that. So there we go. We've got our lovely equation here. So we better get we need to fit a trend line. And we better get this actual equation up, because we probably will need this for part B. So we've got, I'm just going to do y is equal to 2169.3 788 minus 12.50699 so here we go. There's our lovely trend line. So we will. You'll notice there I've put all the decimal places, because it hasn't said anything about how many decimal places we should use, and also is that we should use all the decimal places until the very last step. So now it's saying how many government schools are predicted for Victoria in 2015 if the same trend continues. So 2015 would be, well, we've got 1982 here, so that's at number 12. So how far away would be 2015? Well, 2015, well, let's go and have a look. How many years away would that be? So let's do 2015, take away 1992. So that's 23. So add that to 12. So that's at the 35th year. So what I'm going to do is I'm going to go and find, because that's where we're at 1982. So we're going to go and find the number of schools. So that was going to be the y value, so number of schools is equal to 2169.3788 minus 12.50699 times 35. I'll just type that in. 3788 minus 12.5. In fact, I might just put that in brackets. 12.50699 times 35. And that should get me, I need to round to the nearest whole number. So this case is 1,732. Example 6E.2. The deseasonalized quarterly sales data from Mikey's or Mickey's shop are shown below. Determine the equation of the trend line and interpret the slope. So let's do that. Got to put in all these values. Oh, good. I don't need to get rid of list 1. I can just go and delete list 2, delete column, and do my little linear reg. And we should get, we want to, does it say how many decimal places? It doesn't. So really we should be using all the decimal places that we can. So this is going to be sales is equal to 837.98485 plus 32.066 434 times, what are we? We're times quarters or times time. We can use that. So what this means is, so we have to interpret the slope. So that's this number's 32.0664. So we have to go back to our days of interpreting and using that lovely little formula sentence that we've used before. So this would be, on average, the number of sales increases by, I suppose this is money, isn't it? So $32, and since it's money we can round up, so $32.06 per quarter. If summer year 1 is quarter 1, what deseasonal sales are forecast for winter in year 4? So this is where we need to make sure we know our seasons and the order. So that's going to be summer. So that's going to be every one. So summer, so what comes after summer? So that's going to be autumn, then it's winter, then spring. So 1, 2, 3, 4, 5. So this is summer again. 1, 2, 3, 4. Summer again. 1, 2, 3, 4. So summer again would be 13. So winter is, so we want in year 4, don't we? So that's winter, and that's winter. So we'd be, what do we need to do to get from 3 to 7? Well, we had to add 4, didn't we? So to year 3, we add 4 more, that gets us 11. So adding 4 more, so that's going to be when t is equal to 15, because 11 plus 4 gets us 15. So I'm going to put sales is equal to 837 point, and again 98485 plus 32.0666434 times 15. So again, 32.0666434, 15 plus 837.98485. So we're looking at $1,318.98. 6E.3. The time series shown charts the change in interest rates over a period of years. A trend line has been fitted to the data as shown. The equation of the trend line is closest to what? So we need to go and work out what this is. So this again is not really a time series question. This is just all about using our previous knowledge from chapters 3, 4, and 5 to work this one out. So the first thing I would do is just remember that this number up here, so this first number in each of these is the intercept. Now, thankfully, we've got our intercepts all here, thankfully, and it starts at 0, so I can actually use the numbers on here. So it's about 17-ish. So it's approximately 17. So whichever one has an intercept around about 17. So, yep, so we can eliminate this one. So anything that doesn't have a 17 in it, we can eliminate. So it's either got to be C or E. Now, you'll notice they've both got 1.1. One says a plus, one says a minus. The line's going down. So rather than wasting your time trying to work out the gradient, so as rise over run, gotta be E. It's going down. So that would be the best and quickest way that you want to go and figure that one out. 6E.4. The following deseasonalized data represents the monthly turnover in millions of dollars in a department store over a period of 3 years. Plot the deseasonalized data given T equals 1 represents January 2016. And then we're going to have to determine the equation of the least squares line. Use this line to estimate the turnover for August 2018 and then forecast the turnover. All right. So what we're going to need to do is we're going to need to go and do a whole bunch of some calculations here. So you'll need to plot the data accordingly and get a lovely regression line going. So let's do that. I have entered the data, and now what I'm going to do is I'm going to go and get the equation of the least squares line. It says round the slope and intercept to 3 significant figures. So I'm going to go calculate regression linear reg, list 1, list 2. So 3 significant figures means we start from counting from where the first non-zero figure is. So A is a little bit easy because it's 275 is 3 significant figures. So what is this? Is it sales? What are we doing? Monthly turnover millions. So yeah, well, why not call it sales or income or something like that? And it's deseasonalized, isn't it? Yeah, deseasonalized. So deseasonalized sales is equal to 275 and 1.24. So 3 significant figures is 1.24 times time. The great joy about time series is that the explanatory variable is always the same. It's always time. And there we go. We can now enter that into, now we'd plot that into our graph. Again, I'm going to be super lazy. Use this line to estimate the turnover for August the 2018th rounded to 1 decimal place. So the one thing we need to be aware of is that it says that the turnover, it doesn't say the deseasonalized turnover. So it means we're going to have to do a few extra steps. So August 2018, so we're going for, haven't we already been given 2018? All right, sure, why not? So August 2018 is going to be 1, 2, 3. So that which is here, we need to estimate it though. So we're probably having to compare between the actual value and the, as in the deseasonalized value, the real deseasonalized value and the actual deseasonalized value. So that's at 12, 24, 32, 33, 34, 34. Yeah, so that's going to be T equals 32. So we're going to deseasonalized sales will be equal to 275 plus 1.24 times 32, which gets you 1.24 times 32 plus 275 is $314.68. Actually, no, it's in millions, isn't it? That's right. That's another trap. It says they're in millions. So please don't say that it's $314. It's actually $314 million. So we know that the seasonal index for this is 0.834. So the actual will be 314.68 times by the seasonal index of 0.834, and that's going to be equal to 262. So let's make that into millions of dollars to round decimal place. So we can actually just times it by 1 million, and so that's 262,443,120.0. So that's the estimated value that it would be. Forecast the turnover for May 2019 rounded to 1 decimal place. So this is 2018, so 2019 will be the next one along. So May it is May, isn't it? So May is, so if this is t equals 36, May is the fifth one along, 1, 2, 3, 4, 5. So 36 plus 5 is going to make that 41. So I know that deseasonalized is equal to 275 plus 1.24 times by 41. 124 times by 41 plus 275 is equal to 325.84. So the actual is that for May, what's the seasonal index for May, is 0.966. Is it 966? Yes, 966. Times 1 million. So it's going to get me to 314,761,440 million dollars. And that's forecasting. And the end of chapter 6.